Rocking M Studios presents a Meads Steel Education production from the Second Life University of Patton Bay at Midnight Springs, Washington. Real-life learning in Second Life. Wild World of Science. Video read-along. Chapter 1-3, Energy Flow in Ecosystems. With UPB Professor Callum Dixon.
Greetings, my fine young scientists, and welcome back. Today's reading continues your journey into understanding the relationships between our biotic, or living world, and the abiotic, or non-living environment around us. As always, press pause or rewind the video as needed during your learning. Let's get started, shall we? Chapter 1-3, Energy Flow in Ecosystems. Just as the law of conservation of matter tells us that matter cannot be created nor destroyed, and only changes form, the law of conservation of energy tells us that energy also cannot be created or destroyed, but only changes form. In Chapter 1-2, you learned that the biogeochemical cycles transfer matter between the abiotic and biotic environments. In this chapter, you will learn how energy is transferred between the abiotic and biotic environments. Energy pyramids. An energy pyramid is sometimes referred to as an ecological pyramid or a trophic pyramid. An energy pyramid is composed of several zones, each representing a different trophic, feeding level. It is shaped like a pyramid to depict how much available energy there is at each level. Notice on the energy pyramid shown to the right that the widest level is the bottom, producers, and that each level moving upwards gets smaller and smaller. This is because the most energy found is found at the base of the energy pyramid, or the producer autotroph level, and the amount of available energy decreases at every level moving upward. The least amount of energy available is at the tertiary trophic level. Most energy gets used by the organisms within each trophic, feeding level for life processes, and some is lost to the environment as heat. As a result, only 10% of the energy available in one level gets transferred to the next trophic level. Question 1. Why do we use a pyramid shape to show the flow of energy in an ecosystem? We use a pyramid shape to show the flow of energy in an ecosystem to depict how much energy is available at each trophic level. To list the trophic levels of an energy pyramid, we start at the bottom and move upward in the direction of the flow of energy. Moving upwards from the bottom, the feeding, or trophic levels of energy pyramids are producers, autotrophs, primary consumers, secondary consumers, and lastly, tertiary consumers. Producers, autotrophs. These are green plants and other photosynthetic organisms that capture energy from sunlight, abiotic, and convert it into energy stored in the bonds of glucose molecules through the process of photosynthesis. Primary consumers, heterotrophs. These are always herbivores, organisms that feed on plants. Secondary consumers, heterotrophs. These are always carnivores, organisms that feed on other animals. Tertiary consumers, heterotrophs. These are always carnivores and usually apex predators in their ecosystem. An apex predator is a top predator in an ecosystem and usually has no natural predator of its own. Energy pyramids do not go beyond the tertiary level because there is not enough energy available to support another level. Omnivores, consumers that eat both plants and animals, fit in a trophic level based on what they are eating at the time. For example, A grizzly bear can be a tertiary-level consumer when eating other animals, and a primary consumer when it's eating berries. Decomposers, which break down dead organisms and return their nutrients to the environment, are found at all trophic levels. This means that decomposers are the only organism in a food chain that can get their nutrients from any other organism. Decomposers include organisms like bacteria and fungi. Question 2. At what trophic level can decomposers be found? Decomposers are found at all trophic levels. Food chains. A food chain is used to show a linear pathway of the flow of energy in an ecosystem. Food chains show feeding relationships directly from producer to primary consumer, to secondary consumer, to tertiary consumer. The arrows in a food chain diagram show the pathway that energy takes. In other words, the arrows point directly from one organism to the organism eating it. Question 3. What is a food chain? A food chain is used to show a linear pathway of the flow of energy in an ecosystem and shows feeding relationships from producers through tertiary consumers. Question 4. What direction do the arrows in a food chain face? The arrows in a food chain diagram show the pathway that energy takes. In other words, the arrows point directly from one organism to the organism eating it. Food webs. In nature, it is very unlikely that an organism has only one food source. To show more accurate and inclusive feeding relationships in an ecosystem, a food web is used. A food web is similar to a food chain, but the arrows generally show multiple energy pathways, as more than one organism consumes those organisms below it on a food chain. Keystone species. Organisms within an ecosystem that play critical roles in ecosystems are known as keystone species. The influence of keystone species can be seen in feeding relationships and beyond. As apex predators, many keystone species keep populations of prey organisms in check, and some, like the North American beaver, have the ability to change the physical environment of ecosystems as well. Chapter 1-3, Essential Understanding Summary. Energy cannot be created or destroyed, but only changes form. Energy moves through an ecosystem from the sun to producers, primary consumers, secondary consumers, and tertiary consumers. Only 10% of the available energy in each trophic level gets passed up to the next level. Most available energy in each trophic level gets used by the organisms in that level for life processes. Some energy is lost as heat at each trophic level. And finally, decomposers, fungi, and bacteria are found at every trophic level and return nutrients from dead matter back into the environment. That concludes the read-along section of your Chapter 1-3 assignment. Work independently to complete both the key vocabulary and review question sections. You can find definitions for the key vocabulary provided under modules on your course Canvas page. When you've completed the chapter assignment, remember to share your document with me for assessment. Until next time, be safe, make good choices, and I'll see you again soon.